So what I'm really interested in here before we actually solve the problem is if someone would share how they thought about the problem before they actually started the writing down of the actual algebra. So how did you think about it? And then actually in my first class, we did this with 3 different people and we got 3 totally different approaches. It was very interesting. So anybody willing to share how you thought about it? Yeah, Caitlin?
Well, I thought of the $276 as 60% of the actual price.
Okay, so we'll start there. Okay, so she thought of $276 as 60% of the original price. And why did she get 60%? Why did she say it was 60% of the original price? Yeah. Right, because the original price had 40% of it deducted from it. Anybody think of it any other way? Everybody did exactly the same thing? You have 276 equals 0.6x.
I was just working on it. I did it from the opposite direction.
That's fine. Yep.
40%.
Okay. 276. Okay, hang on. 276 plus 40% of what, Andy? What's x? The original price. So Andy thought of it the other way. 276 plus 40% of the original price equaled what, Andy?
I had worked it out, yeah.
No, I don't. What's this equal to? This plus this. The 276 plus 40% of the original is going to give you what? Is the same as what? So you have the discounted price.
Yeah.
Plus the amount of the discount.
Yeah.
Is going to give you what back again? Okay, so you don't know. It's the same as what? Does anybody want to fill in that? The original price, the same as the original price, right? Did anybody solve this as a proportion? Yeah, Ryan? Perfect. That just shows me you had a great elementary school education. This is just a private joke. Okay, so he's saying that 60 is to 100 as 276 is to x, where x is your original price, because 276 represents 60% of the original price. Okay, so those are 3 different ways. And again, I want to keep pointing out that the idea for most of us of using proportional thinking is lacking, and it's not our fault. Proportional thinking is not emphasized to the degree that it should be in lots of our early math education. So here's 3 different ways of thinking of it. I drew a diagram for the first 2 ways, but not the third. The third I should have gotten out like a sheet with 100 squares in it, but I didn't. So, because I was surprised that people came up with this third method. So let's take a look at what these 2 pictures look like. So this would be Caitlin's way of thinking about it right here. This is Caitlin's way visually. In many of your other ways. This represents the full price of the camera. This little yellow semicircle represents 40% of the whole thing. I mean, I know it's not proportion here. If you take that away, you wind up with your discounted costs. What's the amount of dollars that this purple square rectangle represents, Katie? Anna? Yeah, so this would be like your 276 right here. This whole thing would be like your x, or whatever variable you decided to assign to x. X being the original cost of the camera, the original cost in dollars of the camera. Then you took a piece of this, 40% of it, 40% of that picture is just this little semicircle. And when you subtract those two, you wind up with your final discounted price. So the key to this problem is also being able to represent, you have two expressions here. You have x and you have 0.4 times x. You need to be able to say what those are in words. Once you do, then you can put together the idea of how you get the 276. So 0.4x represents, how would I say in words what the 0.4x represents? Anybody? Yep, Jesse?
The price reduction.
Right, the amount of the reduction, right. Yep, the amount of the actual deduction or reduction, right? So, and that's in dollars. So the way Caitlin thought about it is she decided to start with the whole and take away the discount, and that equals what's left, the 276. Andy thought about it this way, even though he couldn't quite get the whole thing because he came in a little late. Andy said, I'm going to start off with my discounted price, and I'm going to add the discount, which was 40% of the original price. And together, those two things, the 276 plus the 0.4x, gives me x, the original price. So you could solve this with using a couple of different equations, but what doesn't change is what x represents, the original cost, and how you represent the discounted portion. So whether you say this, x take away 0.4x equals 276, or whether you say this, 276 plus 0.4x equals x, you'll get the same answer no matter which approach you take. In both of these, you have to know how to combine like terms. And what you forget is you forget that this is a 1 right in front. So you have 1x, take away 0.4x. So that says $276 is 60% of the original price. So that's where the proportional idea comes in. So this is 0.6x when you combine this. And so this says, another way some people approached it is to just say 60% of the original price is 276. Okay. And then if you solved it this way, you would subtract 0.4x from both sides. Again, remembering to put that 1 as the coefficient in front. 276 is 60% of x. And then when you solve for x, you're going to get what? 430? Is that what it was? 460? Okay, so x is 460. Okay. So there's a lot of things going on here, folks. There's understanding the problem. Visuals help sometimes, just trying to get a sense of what's going on. Writing it out in words helps you. The original price of the camera, take away the discounted price equals, or the reduced price plus the sales reduction is the original, or 60% of the original price is 276. There's lots of ways of thinking about it, or the proportional way of thinking about it. 60 is to 100 as 276 is to 460. Let's take a look at that. 276, that's the discounted price, is to 460, the original price, as 60 is to 100. And if this proportion is true, then the cross products are going to equal each other. So 276 times 100 should equal 460 times 60. Let's see if that works. So this is 27600. And does anybody have that? Well, if you do this out, you'll get 27600. So the amount, this fraction right here, 276 is what part of 460 is the same as 6 out of 10 or 60%. That's what that says. Okay, so the key when you're doing problems in this class, the first step on a quiz, this would have been worth 2 points because you used an x and then you used a 0.4x. So if you just say what x is and you don't say what 0.4x is, you get 1 out of 2 points. If you just say x is the camera, you don't get anything because x is a quantitative variable. It doesn't stand for a camera. Is it a digital camera, an old-fashioned Canon? It's not a qualitative thing. So X needs to be described, so you read the description as a numerical thing. So it's the original cost with the unit dollars of the camera. This is the amount of the price reduction in dollars. Okay, so you just don't say X is the camera and 0.4X is the sale, okay? Because it's not a quality, it's a quantity. That's what a variable represents. But isn't this pretty? I just thought of this today. I never did this before. I think it represents the algebra. Did this help anybody or help see what the algebra does? Or yeah? Okay. All right, so let's move along. We've got one more. Before you start working on your own. So let's see. Tom, you want to read this for us?
Section deals with models and applications we'll call them story arc. One of our goals today is to develop and help to solve the story arc.
So I don't know how many years ago I invented story opportunities. And the reason I did that is I always felt like the minute you said word problems, all these horrible feelings came flooding back into students' minds and bodies. And some people have a visceral reaction to the term word problems, like their stomachs get sick or their palms start sweating. I mean, it's horrible. And I sort of had, this anxiety that comes with it. So in order to try to reduce this, I'd like to call it a story opportunity. It's just a story that's being told, and you now have the opportunity to show how brilliant you are. Okay, so that's how we're going to start thinking about these things that we used to call word problems. They're an opportunity for you to be successful, which I think changes your whole mindset about it a little bit. Okay, so here's one. This diagram was taken from our book. And do you want to read this for us, Liza? Okay, so you have a graph here that shows you the height of the bar here represents the average annual salary of people that earn bachelor's degrees. It would have been nice to see associate degrees in here. And then this next one shows you the master's degree, and you can see the average annual salary is a little higher. Okay, so when you read something like this, where do you begin? Where do you begin? We're going to do this together, but what do you usually think about when you see something like this? You see a less than, and what do you see as less than what here? Okay, so you immediately start thinking about, look at this thing right here. This kind of sticks out for you, and you try to put that into some kind of algebraic expression. All right, then, or you skip over that and you go to the 116. You filter it out. When you look at the 116, what does that mean to you, Jesse? There's an equals there. Okay. How about someone else? How do you begin when you think about something like this? That's how Jesse thinks about it. How about someone else? Yep. Okay. Anna? Good. Okay, so you think about how many variables do I need to solve this, and then you have to represent one of those variables in terms of the other. Yes, good. Okay, let me just tell you that you can do this problem using two variables, or you can do it using 1. And today we're going to do it using 1, and then on Wednesday we're going to do these problems using 2. But you can do it either way, because the way we do it with 1 is what you end up calling the other variable. So we're going to do it with 1 variable today. Section 1.3 of your book, which is where we are, uses 1 variable. Okay, so first you have to know what you're looking for, right? What are you looking for in this problem? One thing or 2 things? 2 things, right? And that's where Anna said, oh, I would have 2 variables, and that's fine. The average annual salary of people who have a bachelor's degree and the average annual salary of someone who has a master's degree. But the 2 have to talk to each other. You have to be able, if you want to put those 2 together, in fact, if you put those 2 amounts of average salary together, what do you actually get? 116,000. When you put the 2 average salaries together, you get the 116,000. So let's go through a series of steps that I've outlined for you. This is sort of how my series of steps, you won't get this in the book. This is something that I put together. And let me just say, a lot of times you don't want to take the time to go through and do all of this. But these are really the series of steps that helps you begin to take apart these stories, use the information that you need from each part of the story, put it together to create an equation. Once you get the equation, I heard Dylan say, once you get the equation, it's easy from there. It's getting the equation that's the hard part, right, Dylan? So he was talking to Hannah earlier about that. It's just getting to the equation is the hard part, and I totally agree. That is the hard part. Okay, so read the problem carefully, identify/describe in words the quantity of quantities you're being asked to find. So that's what I'm going to do. I'm going to say, I need to find the average salary for those who earn a BS or BA, all right, degree? And I need to find, and you can use like little quote marks, the average salary for those just who earn master's degree. All right, so that's just in words. Then I have to assign a variable or variables. You can do 2 here if you want, but I'm going to do it with 1 today. Assign a variable, you can call it X or whatever you want, to one of the unknowns, unknown quantity. Then how do we decide about which of those quantities we're going to assign X and which one we talk about in terms of X? That's a big decision. So when you read this first sentence, the first sentence helps you to decide which one to call X. And has someone figured that out for themselves? Which of these 2 average salaries you would call X and Y? Other than Anna? Someone else maybe? How you decide? You can do, it doesn't matter, it's arbitrary, but one way is going to be a little easier than the other because of the phrasing of the first sentence. Isabel? Would X be the bachelor's degree? If we did say X was the average salary for the bachelor's degree, can you now easily talk about the average salary of the master's? With an expression, yeah. Okay, you used a B instead of X? Is that what you used? Okay, that's fine. I just want to use the same variable you did. Okay. So B is the average salary of the for the people who earned a bachelor's. And then what did you say would be the average salary of the master's? M. Okay. All right. So you use 2 variables. Okay. So how do we describe M in terms of B? Right. Okay, so here you go, folks. Here it is all in one statement. Whether you use 2 variables or 1, in order to solve this problem, you can't just say B plus M is 116,000 because that's one equation with 2 pieces you don't know. You'd never be able to finish it. That's like a straight line. You'd have an infinite number of possibilities. You have to be able to say what either B is in terms of M or vice versa. So how did Isabel decide that she was going to talk about M in terms of B? We say M here is written in terms of B, because remember I told you that the pieces of this expression is called terms because it has an adding and subtraction there. So how did we decide that M was going to be expressed in terms of B? Why didn't I say B was equal to, let's see, M plus 49,000 divided by 2? Why didn't I do that? Why didn't I say B was M plus 49,000 divided by 2? Why did I choose this route? It's simpler. Why is it simpler? Oh, you like multiplying better? Yeah. It doesn't have fractions. All I'm trying to get at, folks, is because this is what the sentence tells you to do, right? The master's degree is. So if you want to think about it as M, the average salary for the master's degree is, and then they talk about a relationship in terms of the bachelor's, okay? So they're telling you to find the average salary of the master's degree. If you tell me the bachelor's degree, this is what I do to it. I take that amount of money, I double it, and then I subtract 49,000 from it. So it's the way it's phrased. If I had changed this to say the bachelor's degree is $49,000 more than the master's, half of $49,000 more than the master's, then you would have had to do something different. That's not the way the sentence is expressed. All right, so we're going to assign a letter or a variable. We've done it. Write all other unknown quantities in terms of this one variable. So if you said B and M, then you would have had to express M as 2B minus 49,000. So B is going to be the average salary, blah, 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 for the bachelor's. And 2B minus 49,000 in parentheses is the average salary of a person who has blah, 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 a master's degree. Okay. So to be or not to be, that is the question. Okay. So now we come to the part of what is equal to what. Can you just tell me in words what is equal to what in this story? Is B equal to M, or is B equal to 2B minus 49,000? No. What's equal here? So you're just saying this is equal to 116,000? The average salary of a master's? No. Yeah, isn't it both of them, right? Combined, it says. So if I take the average salary of the bachelor's and I put it with the average salary of a person who earns a master's degree, that together represents the 116,000, right? So once you define your variables, in order to come up with an equation, you certainly have to decide what equals what. And the sum of these two degrees here is 116,000. I don't want to put units on it unless I put units on everything. So I'm just going to put the numbers here. Okay. Now from here, as Dylan said, once you get the equation, it's easy after this. Huh? Oh, I got to put some zeros in here. Thank you. Yeah. Okay, so you got 1B and 2B gives you 3B minus 49,000 is equal to 116,000. And then in order to solve for B, you have to add 49,000 to both sides. So you get 3B equals 165,000. Then you divide both sides by 3. And you get the amount, the average salary of a bachelor's degree that you would earn in a year, and that's 55,000. Okay. So to find, remember, you have to answer the original question that was asked. So what was the original question? Find average salaries of both. So now you go back, there's the bachelor's. To get the master's equaled 2 times the bachelor's, right? Minus 49,000. So that's 110,000 minus 49,000, which gives you what? $61,000? Okay. Yeah, go ahead, Christopher.
I mean, that's take a lot of time.
Yes. I was just going back to because this is how we defined it up here. We know that B plus M is 116, yes. So you could have just, as Christopher pointed out, you know your total is 116. You know so that comes from this idea, the bachelor's plus 2B minus 49,000 equals 116. So the two together, let's make this a single variable like that. So the master's is 116. The average salary of the master's is the total minus the one you found out. Yes, that will give you 61,000 as well. The reason I went back to this method is that's how we defined it back here. It's twice the bachelor's minus 49,000. But they both give you the same answer. Any questions on that? Okay, so you've got another problem at your on number 3 that deals with text plans, the cost of 2 text plans. Work on that. When you're ready to have it checked, call me and I'll give you a little check, and then you can start working on the 3 problems I gave you. Okay, so let's take a look at the monthly text message plans. One plan starts off with a higher starting point. This would be like your y-intercept if you were to graph this. You're going to start your graph at 20 bucks before you even send any text messages. And it's going to go up with a slope of 0.05 per text, 5 cents per text. Your next plan starts lower on your axis. Right? So if we were to graph this, this would be like plan A. It starts higher and has a slope. Plan B is much lower. It starts at $5, but it's got the slope is twice as big. It's 10 cents per text. So it's going to be much steeper like this. Okay. So you can see that until a certain point, plan B, because it's only 5 cents, it starts off at just $5. For a certain amount of text, plan B is going to cost less than the blue line, plan A. Then they're going to hit their equilibrium point. At this point is what you found when you just solved that equation. At that point, which you should have gotten 300 texts, both plans are going to equal the same cost. And then after that, they switch roles. After that, plan A is less because it has a smaller slope than plan B. So there's a lot going on here. This is what your graphing calculator will show you. We'll take a look at that in a minute. Yeah, Jesse?
When I did the check,
Yeah,
wow.
they didn't. Okay, well, why don't we see? All right, well, let's, did you get 300?
Yeah, I got
Okay, well, we'll check it in a minute, okay? Just relax. Don't get all sweaty or anything, okay? All right, so we've read the problems. We've identified what we're looking for. What are we looking for here? What are we looking for? That will what? What will be equal to? So we're searching for the number of text messages that will what? Right. What about both plans? I know I'm sounding like I'm being picky, but it's important. The number of text messages that will what?
include video, photo.
That, well, the price of both plans will be, right, where the price of both plans will be the same. That's what we're looking for. Okay, so you've got to kind of get a sense of what you're looking for before you can do anything, all right? So we're going to assign a variable to one of the unknown quantities. Well, guess what? We only have one unknown quantity right now. It's the number of texts that will make both of these costs equal. So we're going to describe what that variable is as the number of texts. It's not text messages, it's the number of text messages. Number of text messages. Okay, so if I had 2 points for this, and you said X is text messages, you'd get 1 out of 2, because you haven't defined it in terms of a quantitative thing. Okay, no other unknown variables here. Well, you might say, wait a minute, how about the cost of the plans? Okay, I'll take that. The cost of plan A and the cost of plan B, we don't know. So we're going to describe both of those just in terms of this one variable. So the cost of plan A starts out at 20 bucks, and then it's 5 cents for every single text times the number of texts you sent. And plan B starts off much less as a starting value, but each text is more expensive. So what is equal to what here? What are you trying to find? You're trying to find when the cost of plan A equals the cost of plan B. And now we substitute what the cost of plan A is right underneath the cost of plan A, which is 20 plus 0.05x equals, and then the cost of plan B right under here, 5 plus 0.10x. Then you solve this equation and you get x equals 300. So 300 text messages means that the cost for plan A and the cost for plan B are exactly the same. So let's take a look. Jesse was trying to check his answer. So let's see if this works out. 5 plus 0.10 times 300. Okay. So 5% of 300. So I don't use my calculators. This is what I do. 10% of 300 is 30. 5% is half of that, 15. So 20 plus 15 is 35. What's the unit on this 35? What's the unit? What am I finding? Dollars, right. And then this is 5 plus 30, which is 35. So the two of them at 300 texts, the cost of both plans is 35. So if you were back here, you actually know the coordinates now. This is your number of text messages on the x-axis. This is your cost on the y. So the ordered pair would have 300 for the first coordinate and 35 for the second. Yeah, okay. So let's take a look at, if you had a graphing calculator, how you would check this out. So I would turn on my graphing calculator, and I would let y1 equal my first plan, 0.05x plus 20, and y2 would equal 0.1x plus 5 in any order you want. Doesn't matter, it's addition. Then I'd have to figure out the window. The first thing I would try would be x is 0. Not knowing the answer, I'd probably put like 0 texts up to like 50 texts if I was, doing this incrementally. And same with the cost. I don't need any negative text numbers or negative cost. And then I'd work my way up because I'd keep looking. So let's suppose I did that. I did this in the first class. I'll show you exactly what I did in the first class. So I went like this in the first class. Again, I know the answer, but suppose I didn't know the answer. So when I asked to graph with that window, here's plan B, A, and here's plan B. So you can see those two lines are really far apart. They're not even close to intersecting, which tells me I need to go much further out on my horizontal axis, which is the number of texts. So I still don't know how many texts. So I go back to my window and I say, okay, why don't I try 150 and see how far I get? So I do that. There's plan A. There's plan B. You see a steeper slope. I'm getting closer, but I still have a distance. So it's a game you play of using some common sense. Oops, sorry, I meant to do the window. And just watching. So I don't know how far to go. Let me go up to 250 and try that. Okay, because I haven't done the algebra. I'm trying to get my calculator to show me the answer. Okay, ooh, I'm almost there. So now I know I'm really close. So I might go up to say 350. Here's plan A. Plan B starts much lower, but steeper slope. Boom, they intersect. And now this is the fun part. You say second calc, you go down to intersect, and you go enter, enter, enter. And there's your answer. 300 texts for $35. Yep, Chris?
Can you do the intersect thing without like going through that process? Like typing it out?
Oh, without seeing it? You know, I've never tried that. Let me take a look. What happens? Let me get a picture of this first. Okay, I always got to have that camera open. I keep forgetting. Well, let's see if it works, because if it does, then that's true. You would save a lot of time. I don't know if you can ask it to intersect when the window doesn't go out that far, but let's take a peek. So let's go back. That's a good question. So Christopher's saying, so what if we didn't go out that far? Let's just say we did the 0 to 10, and we had 0 to, we knew that neither one of those could be negative, and let's suppose we just did that and we got this graph. They're going to be really far apart. In fact, you can't even see the one with 6. Why is that? What's going on here? Well, starts at 20 and I almost went to 10. There you go. 20. All right, so you got to at least look at your y-intercepts. Plan A starts at 20, so you got to have at least a 20 there. Right? There you go. All right, so there's plan A. It almost looks like a straight line with no slope, really far apart. So now Christopher's saying, do you really have to adjust the window to get that intersection point? I don't know the answer, so let's try it. Second, calc, go down to intersect. First curve, guess, enter. Second curve, enter, guess, enter. It's really thinking hard. Look at it. Quit. No sign change. So there's nothing, you have to have the intersection to show that. Okay. The what? Y min is the smallest. 0, because you're not going to get a cost less than 0, right, for your monthly plan? Okay. So good idea, Christopher, but it didn't work, unfortunately. That would save us some time. All right. So you now have, and this is what you have 15 entire minutes left, and you have 3 problems here. Oops, not here. 3 problems. What I suggest you do is you look at all 3 of them, try the one you think you would need the most help on while I'm still here or your classmates are here. Please don't start yet because I'm not done talking, okay? The other thing is, someone said to me at the end of the first class, do I have to do all of these? Now, I'm not going to collect this, but any group activity that I have as part of the lectures is there for you to do. Even though I don't assign a 1, 2, 3 or a 10 on these, you could see any one of these problems on Friday's quiz or your first test. So do you have to do them? I'm not going to tell you you have to do them. I think it would be wise if you did them. So if you have some time to finish these up before Wednesday and you have questions, then between 10 and 10:40, you can come and see me and I can help you with them, or you can go to the studio. Okay, so the expectation is this. Any activity at the end of any class lecture, you are responsible for. Whether you do it or not is totally your decision. Okay?